What's up guys? So karon sample problem ta no about cable subjected to concentrated loads. So this is just a walkthrough on the solution on how to solve this particular problem. Specifically this cable that is subjected to concentrated loads. So first let's analyze what's going on in this given problem. So here we have a cable ABCD. So originally our cable is something like this. Ano na siya originally? From A to D. But then as we apply this 3 kilonewton load here and 8 kilonewton load here, napurma siya ingani, nisag ang ato ang cable. So the sag of this due to this 8 kilonewton load applied at point C. And if we measure that from point A here, its sag is 4 meters. While if we measure that at point D, its sag is just 2 meters. And then this 3 kilonewtons, this is what we need to find. We need to find the H, or how much is the sag brought to us by this 3 kilonewton load. And also, what are the tensions in each of the segment. Since this loads is acting on the cable, then the cable should also exert a force so that it can support these loads, diba? So that it will maintain equilibrium and the cable will not collapse. So that's our main essence of calculating the forces. Now, asa man ta magsugod? If you look at each point, they say that if we have this kind of problem, pwede daw ta mo take og sum of the forces in the x and in the y at each point. Let's say at C, tanaw na to. Pwede ta maka-take og moment diha, forces x and forces y diha, but not moments since single point naman na siya. Diba? Also at B, at A, or at D. But then as we can see, kung tanaw na to dire sa B, if we take some of the forces on that point at B, there are maximum of how many unknowns? 4. Why? Because this tension in AB is unknown. Tension at BC also unknown. And if we look at the inclination of AB with respect to horizontal, still we don't know what's the angle. Also for BC. Wala po ta sa C, same problem. Although makakuha ta og sa may atong makuha dire na atay angle due to this geometry, 2 rise and 1.5 run. But here, naapatay usang unknown. What kabalo what is? We only have 2 meters but we don't know what is this height. Ba? So our total unknown for point C is the tension in BC, tension in CD, and the angle BC. So what now? Asam ta magsugod? So the very genius idea to start from is to take moment about A. So if we take moment about A and let's say we cut this rope here or the cable right there, then that cable should exert force so that it will balance this out. So it can balance these forces acting on the left side. So if we draw the free body diagram again of ABC and the cut, we will have this. We cut here. So this is tension CD. And we have here the 8 kilonewton. And here the 5 kilonewtons load. And here this is point A. But with its reaction, something like that. So as we cut here, we isolate the left side. And then we have this free body diagram. Now for the slope of CD, this one, we can say that is in 3, 4, 5. Why? Because if we double this 1.5, what do we get? 1.5 times 2 is 3, right? And then 2 times 2, or we double the 2, it's 4. And then there is this relationship of right triangle wherein we have 3, 4, 5. That's a special case. So that's it. We have the slope of CD. And also we have the dimensions. So this is 2 meters here. And also 2 meters here. And then here, this one, we have 2, 2, and 1.5. So this is 2 meters, 2 meters, and 1.5 meters. Right? These are the dimensions. Now, let's proceed to what I've said a while ago. I've said that mo take ta og moment at A. and that should be equal to 0 to maintain equilibrium, so that this cable will support the loads. Now, some of the moments at A. First, we break down this to its components, because it will make it easier to find the moment if naka-components ang ato ang TCD since it is inclined. So if we do that, the vertical component of CD is just 4/5. That's 4/5 TCD. And its horizontal is just 3/5 TCD. Just like that. Now it's easier to take the moment. Summation of moment at A, all the forces that cause counterclockwise rotation about A is equal to all the forces that cause clockwise moment at A. So what are these forces that cause counterclockwise about point A? So this is the distance, 2 meters, right? So that's 3/5 TCD. And then any other force that cause counterclockwise? Of course there is. Kini. This is moment arm. Natanan. So for 3/5, its moment arm is 2. This one here. And then this 4/5, its moment arm is this whole 5.5. So plus the horizontal vertical component, this one, TCD, that's multiplied by 5.5, the moment arm. So that's all the forces that cause counterclockwise rotation. And that should be equal to these forces that cause clockwise. So for 5, its moment arm is 2. I mean, this is 3. Sorry. This is 3. Right here, this is 3 kN. So that should be 3 times 2 plus 8 times 4. Right? This is 4. So all the counterclockwise is equal to clockwise. So as you can see, our only unknown here is tension CD. So now if we solve that, we'll get tension CD is equal to 95/14 kilonewtons. So that's about 6.79 kN. So we're done with the first. So we need each. So we only need BC, AB, and H. Now that we have that tension CD, we will proceed to point B here. Because we already have this CD. So ano na ta din to solve for BC. And AB as well later on. So if we draw the free body diagram of point B, we have like that. And this 3 kilonewton load. Ito ba? Or I guess we should do point C first. Point C sa ta. Sumni ang point C. Ba? Kini. Na siya. So, this is tension CD. And that is equal to 95/14. And its slope is 345. Again, 345. And then, here, we don't know what is this angle here. That BC. So we will have here two unknowns, which is tension in BC and the angle of inclination of tension BC or in BC. Right? We know the tension in CD. We have the given 8. So we have two equations. And how many we have two unknowns. And how many equations can we get from point C? There are two. Some of the forces in the X and some of the forces in the Y. So this is tension BC. This is angle theta BC. We don't know that, but we know this 8 kN and 95/14. So if we sum all the moments, the forces in the Y direction, so this has a Y component, also this one, alright, that's the only forces acting. Sum all the forces in the Y direction and equate it to 0. Then TBC sine, this is sine of theta, this component is TBC sine of this angle, and this one is 4/5 of this value, right? So we will then have TBC sine of theta BC. So this is just the component of this force. And that's equal, plus pa di ay, since they are on the same direction, 4/5 of tension CD. And we know that tension CD is 95/14. So, this is 14. And that's equal to 8. Alright. So that's our first equation, which has two unknowns, TBC and theta BC. In order for us to solve the two unknowns, we need second equation, which is sum of the forces in the X. So for sum of the forces in the X, we have this component. So this one, that's 3/5 of this value. And here, for the other component here of TBC, tension BC, that's TBC cosine of this theta BC. Right? So we only have two forces acting on the horizontal, and they are equal to each other. So by that, we can say that 3/5, or let's write this first, or whichever you want. So TBC cos theta BC, the horizontal component of TBC is just equal to the horizontal component of tension CD, which is 3/5 of tension CD, or 95/14. So, ano siya? Dire ka ni. Dire. Alright? So, this is theta BC, and this is its slope. Ano sila? Right? We have unknowns BC and the angle. So, you can see here, kini nga ito ang solution dire. Right? We have two unknowns, TBC and theta BC, TBC and theta BC. Ano siya ito unknowns na to? And since we have two equations, automatic, masolve na to. So, din na ako i-elaborate kayo ang solution ani nga pag-solve. It's just a matter of algebraic manipulation. So, we'll then have TBC and theta BC equal to, for TBC, that's 4.82 kilonewtons. And for theta BC, that's 32.28 degrees. So, how many answers we have knocked down so far? I guess we have two. Tension in BC, and then here, tension in CD. So, we're only left with tension in AB and the value of this H. If we move to point B, you can see, we know this one. We know tension BC. We have this given value. That's no problem. And, again, we have two unknowns. The slope of this and the tension AB. And since we can get two equations at this point, we can solve it again by sum of the forces in the X and sum of the forces in the Y. So, let's draw the free body diagram. This is tension AB. Here, tension AB. This is 3 kilonewtons. Based on this, this is point B here. We know that that's point B. Then, here, we have force that is inclined 32.28 degrees. That's theta BC. And TBC is equal to this one. We've just calculated 4.82 kN. It's like that. And then, what's the slope of this TAB? As you can see here, we have a run of 2 and then a rise of H. So, let's just copy that. This is H. This is 2. And then, how about, since this is a right triangle sa maiyahang hypotenuse, of course, that's H squared plus 2 squared, or 4. So, muna yung hypotenuse. Again, sum of the forces in the X equals 0. Sum of the forces in the Y equals 0. Then, two equations, two unknowns, pwede na nato i-solve. So, unsa may component ani dire? Vertical, this 3, and also the vertical. Mura na sila, di ba, sa forces in the Y. Sum of the forces in the Y direction equals 0. So, how much is this? So, that's this vertical. So, H over square root of H squared plus 4 times tension AB. Na siya, no? Una yung magnitude. And for this one, it's just tension BC. So our angle is here, and the side we're looking for is this one. So we will have TBC sine of this angle, 4.82. And we know that TBC is just 32. Ano siya? So natay equation 1. So this force is equal to the sum of these two. So upward equals downward. So we have H over square root of H squared plus 4 and tension AB. So this right here is just basically that. And that's equal to downwards. So 3 plus 32 sine of 4.82. 4.82. So this is 32.28. Right? Lang. Then, muna ito equation 1. For equation 2, forces in the x direction. Saan sa may x direction. For the x direction, this, parang itakilid kaya para di maagian eh. And this one. So for this one, this is just this horizontal. So 2 over square root of h square plus 4 times TAB. Ano siya? And here, this horizontal is adjacent to our angle. So TBC cos 4.82 rin na siya. Right? And so, rightward force is equal to leftward force. So that's just TBC cos 4.82 or 32 point, nabali ba? Pag nabali, bali ni siya. Dapat 4.82 muna yung atong force times sine of 32.28 which is the angle. And here, TBC cos 32.28. And we know that TBC is just, TBC 4.82. And that's equal to this component. 2 over square root of h squared plus 4 TAB. Oh, as you can see, the only unknown now here is h and TAB. TAB and h. With that, we have two equations and we have two unknowns. Therefore, TAB, or the tension in AB, and the height is equal to 6.90 kN. 6.90 kN, and the height is just 2.74 meters. So that's it. That's how we do this type of problem. And if you have questions, just comment down below. And although my solutions is so messed up, but basically that's how you solve it. Thanks for watching. Peace out.